The next type of element, unilateral and bilateral element. The output of the element is irrespective of the direction of the current flow. Abhina, that is bilateral element with respect to direction of the current flow abhina is an unilateral element. So definition for unilateral and bilateral: the element that provides the same resistance or impedance in both the direction of the current flow is called bilateral. Otherwise, it is called as a unilateral. Another definition: the element characteristics are same even though the direction of the current is changes, is called bilateral. Otherwise, it is called as a unilateral element. The direction of the current flow is change on all, the output characteristics of an element does not change. That is called bilateral. Right? To take an example, just we are taking. So here resistance impedance we are taking is a resistor. So resistor example or resistor, we are giving the supply plus and minus. So resistor R, right? So plus and minus. This is plus and minus voltage source. Current flowing through the resistor is I. So draw the characteristics curve for a resistor. This is I, V. So first resistor is a linear division. So output is with respect to ratio of voltage and current. So this is linear, or that is equal to V by I. Right? This is the characteristics of an resistor. Now changing the direction of the resistor, changing the direction of the current flow, changing the direction of the current flow, that is here minus plus voltage source V, resistance R, here this is plus and this is minus. So current flowing through in this direction, current flowing through in this direction. So upon graphical representation, that is this is current I flowing to the negative and voltage also in reverse, but the characteristics in circuit, that is R, that is equal to V by I. So minus minus cancels, that is also positive, but it is in a opposite direction. So irrespective of the direction of the current flow, the characteristics within it is a linear. This is also a linear, in this direction also linear. So this is called as a bilateral element. So resistor is a bilateral element. So bi means it's a two. So the representation of a bilateral element, bilateral element, this is a four quadrant characteristics are. So bilateral element, characteristics of bilateral element எப்படி இருக்கும்? Just taking current, voltage, this current, voltage, current, voltage, voltage. Okay. So unilateral element, the characteristics is only in positive direction. Only in positive direction, it is called unilateral. This is the element, this kind of characteristics called unilateral. So opposite direction, if the current changes, same characteristics, that is unilateral. Bilateral, the both direction is having the same way, that is called bilateral. This is characteristics for bilateral element. This for unilateral, this is for bilateral. Bilateral na, so inge இந்த quadrantல என்ன characteristics வருதோ same it will be replying in the this opposite, this quadrant. So this called as a bilateral, this is a unilateral element. So example for unilateral and bilateral elements are, so what are the unilateral and bilateral elements? That is, for unilateral element are diode, transistor, SCR, and op op amp. So diode, transistor, SCR, op amps are an unilateral elements. For bilateral elements, resistor, inductor, capacitor and diac. Resistor, inductor, capacitor and diacs are bilateral elements. Fourth type of element, lumped and distributed elements. Right. So lumped and distributed element எதை வச்சு கிளாஸிஃபை பண்ணுறோம் அப்படின்னா பேஸ்ட் ஆன் தி வெலாசிட்டி ஆஃப் தி எலக்ட்ரோமேக்னெட்டிக் வேவ். ஸோ நத்திங் பட் நம்ம இன்புட்டாக கொடுக்கக்கூடிய வோல்டேஜ், தட் இஸ் எலக்ட்ரோமேக்னெட்டிக் வேவ் இஎம்எஃப்னு சொல்லுவோம். ஸோ அதோட வேவ் லென்த்தை பேஸாக வச்சு வி ஆர் டிஃபைனிங் லம்ப்டு ஆர் டிஸ்ட்ரிபியூஷன் ஐட்டமா அப்படிங்கிறத பார்க்கலாம். லம்ப்டு அண்ட் டிஸ்ட்ரிபியூட்டட் எலமெண்ட்ஸ் அப்படிங்கிறத பார்க்கலாம். ரைட். ஸோ வி அப்படிங்கிறது வெலாசிட்டி ஆஃப் எலக்ட்ரோமேக்னெட்டிக் வேவ். எலக்ட்ரோமேக்னெட்டிக் வேவ் நம்ம இன்புட்டாக கொடுக்கக்கூடிய supply, right? So V is velocity of the wave, that is equal to lambda into F. So lambda is wave length of the electromagnetic wave. So lambda is wave length of the electromagnetic wave in meter. F is frequency in hertz or 1 by seconds. Okay. So lumped and distributed element if the types of element or length is equal to lambda, அதாவது wave length க்கு ஈக்குவலா இருந்தது அப்படின்னா that is called distributed element அப்படின்னு சொல்றோம். Wavelength is not equal or lesser than the element ஓட சைஸுக்கு கம்மியா இருந்துச்சு அப்படின்னா that is called lumped element அப்படின்னு சொல்லுவோம். Okay. So the definition போகும். First we have, so based on wavelength of electromagnetic wave lambda, that is equal to velocity of the electromagnetic wave divided by frequency, right? So velocity, the unit of velocity is meter per second and unit of frequency 1 by second. So we can cancel, we get the value is meter. So lambda, that is equal to meter. So understanding purpose we are taking general electric supply. So general electrical supply நம்ம நார்மலா இந்தியாவில் யூஸ் பண்ணக்கூடிய ஸ்டாண்டர்ட் ஃப்ரீக்வன்சி ரேஞ்ச் வந்து 50 Hz. ஒன் மோர் திங், the velocity of electromagnetic wave in vacuum. So velocity of electromagnetic wave in vacuum is 3 into 10 power 8. 3 into 10 power 8 meters. So velocity of meters per second. So we can write here, right? So example for our general electric supply. So example, so frequency that is equal to 50 Hz எடுத்துக்குவோம். 50 Hz. V that is equal to 3 into 10 power 8 meter per second. So இந்த 3 into 10 power 8 அப்படிங்கிறது velocity of electromagnetic wave in vacuum. So இது வந்து that is velocity of electromagnetic wave in vacuum, that is 3 into 10 power 8 meter per second. So 3 into 10 power 8 meter per second, right? So just now we are substituting the value lambda, that is equal to V divided by F. So V is 3 into 10 power 8 divided by frequency, that is equal to 50. The unit is, the length of the is meter. Okay. So now solve, you will get lambda, that is equal to, generally we are getting 3 into 10 power 8. So 3,000 3 divided by 16, that is you can get 6,000 kilometer. So the value of lambda we can come that is equal to 6,000 kilometer. 6,000 kilometer. Basic நம்ம ஜெனரலாக கொடுக்கக்கூடிய சப்ளை நம்ம ஜென்ரல் எலக்ட்ரிக்கல் சப்ளையோட ஃப்ரீக்வன்சி 50 Hz. ஸோ வேவ் லென்த் 3 × 10⁸ வேக்கம் எடுத்தீங்க அப்படின்னா the lambda equal to 6,000 kilometer, right? ஸோ நம்ம யூஸ் பண்ணக்கூடிய ரெசிஸ்டன்ஸ் இண்டக்டன்ஸ் ஆர் த எலக்ட்ரிக்கல் எலமெண்ட்டோட லென்த் இட் இஸ் ஈக்குவல் டு 600 கிலோமீட்டர் இருக்குமானா இல்லை. ஸோ த லென்த் ஆஃப் தி எலமெண்ட்ஸ் தட் வி ஆர் யூசிங் இன் அ சர்க்யூட் இஸ் very low as compared to lambda. Resistor, inductor, capacitor, these are very low. But இதே டிஸ்ட்ரிபியூட்டர் நெட்வொர்க் எடுக்கும்போது டிஸ்ட்ரிபியூஷன் டிரான்ஸ்மிஷன் லைனில் இருக்கிறீங்க. நம்ம டிரான்ஸ்மிஷன் லைனில் இருக்கும்போது 600 கிலோமீட்டர் that is approximately equal to the value length of the resistor, length of the conductor equal ஆகும், ரைட்டா? ஸோ ரெசிஸ்டர், இண்டக்டர், கெப்பாசிட்டர் டிஸ்ட்ரிபியூட்டர் நெட்வொர்க்கில் இந்த டிரான்ஸ்மிஷன் லைனில் you cannot separate. So resistance is distribution line full it is resistance. Inductance also distributor line full length are inductor as well as capacitor between conductor and ground. Okay, so appo this lambda value is more or less equal in a transmission system. So transmission system is more or less equal. So appo so transmission systems are called distributor element. So transmission system is called resistor, inductor, capacitor is called distributor element. Also in our circuit la use பண்ணக்கூடிய resistance inductor எல்லாமே it is less than the value of lambda, so it is all comes under lumped elements. Understand? So lumped element or distributor element அங்கிறது எதை பேஸ் பண்ணி பிரிக்கிறோம் அப்படின்னா based on the value of lambda. Lambdaங்கிறது என்ன? Velocity. So wavelength of the electromagnetic wave. ஸோ அந்த எலக்ட்ரோமேக்னட்டிக்கோட வேவ் லென்த்துக்கும் நம்ம யூஸ் பண்ணக்கூடிய எலமெண்ட்டோட லென்த்தும் ஈக்குவலாக இருந்தது அப்படின்னா தட் இஸ் கால்ட் ஆர் மோர் ஆர் லெஸ் ஈக்குவலாக இருந்தது தட் இஸ் கால்ட் டிஸ்ட்ரிபியூட்டர் எலமெண்ட் அப்படின்னு சொல்லுவோம். இல்லை இட் இஸ் வெரி லோ as compared to லேம்படாவாக இருந்தால் தட் இஸ் கால்ட் லம்ப்டு எலமெண்ட் அப்படின்னு சொல்லுவோம். ஸோ ஹியர் த லேம்படாங்கிறது சப்ளை. ஸோ லேம்படா இஸ் greater than circuit length that is called, so the circuit length விட ரொம்ப பெருசா இருந்தது அப்படின்னா that is called lumped element. So the element is called lumped element. So the lambda is greater than, so lambda is the wavelength of the supply. So lambda is the wavelength of the supply. Same wavelength of the supply is greater than circuit length, less than circuit length இருந்தால் less than circuit length or more or less equal to circuit length that is called distributed, that is called distributed element, that is called distributed element based on the 50 Hz in electrical. Based on the electrical பொறுத்த வரைக்கும் 600 meter length அப்படிங்கிறது it is a very long distance line. அதே மாதிரி based on the frequency it is applicable for transmission and distribution system. So distribution system or transmission system is having a more length, so 1000 km, 2000, 6000, 10,000 kilometers வரைக்கும் இருக்கு. அப்போ it is equal to the supply, the lambda wavelength is more or less equal to or greater than circuit length, so that is distributed element அப்படின்னு சொல்லுவோம். Otherwise it is called as an lumped element based on the circuit length. Circuit is these combinations of elements, resistor, inductor, capacitor, that is a circuit, right? So we are taking one more example related to electronics. So we are taking one more example for electronics, example for antenna. I am taking a frequency that is equal to 100 megahertz. 100, I am taking this is 100 megahertz. So velocity same, that is 3 into 10⁸. So lambda that is equal to 3 into 10 power 8 divided by 1000 megahertz. 1000 megahertz, that is 10 into 100 into, that is 100 into 10 power 600 into 10 power 6 yearly comes to 3 kilometers. So more or less, for example of taking electronics antenna, so frequency another 100 megahertz frequency. இங்கே 50 hertz தான், இங்கே 100 megahertz frequency. Velocity same in a vacuum, 3 into 10 power 18. So lambda, that is equal to 3 kilometer. அப்போ கம்மியா சார் 3 கிலோமீட்டர்னா 3 கிலோமீட்டருங்கிறது கம்மி. பட் தீஸ் 3 கிலோமீட்டர் கம்பேர்ட் டு எலக்ட்ரானிக் சர்க்யூட்டில் 3 கிலோமீட்டருங்கிறது என்ன, இஸ் வெரி ஹியூஜ் சர்க்யூட். எலக்ட்ரானிக் சர்க்யூட் போது ஃபார் எக்ஸாம்பிள் சப்ளை, இது சப்ளை அண்ட் திஸ் இஸ் அ சர்க்யூட், திஸ் இஸ் அ சர்க்யூட். ஸோ 3 மீட்டர், திஸ் இஸ், ஸோ 3 மீட்டர் அப்படிங்கிறது as compared to electronic circuit, PCB board and the electronic circuit 3 kilometer, it's a very huge, very circuit. So this is also comes under distributed element. So lumped and distribution are mostly classified based on the lambda. Lambda is the wavelength of the supply. Okay, so how many meter distance it's cover அப்படிங்கிறது based on that we are classifying the lumped and distributed element, right? So definition for a note point for lumped and distributed element. Lumped and distributed element, note point for lumped and distributed element. Writing here. Also, before going to the lumped and distribution, we have another definition for this lumped and distribution network, that is resistance, inductance and capacitance. Resistance or LC. The same we have resistance, inductance, capacitance. Also we have resistance, inductance, capacitance or LC. This is RLC. So run the circuit. Is it RLC? Your circuit RLC. This is in a separate order in a circuit. Resistance value taniya, inductor value taniya, capacitor value taniya, தனித்தனியா we can able to separate அப்படின்னா that is called as an lumped element. Separation of RLC is possible அப்படின்னா that is called lumped element. அந்த elements என்ன சொல்லுவோம், அந்த சர்க்யூட்டை lumped circuit அப்படின்னு சொல்லுவோம். So separation of RLC possible அப்படின்னா that is called a lumped circuit. So RLC, separation of RLC is not possible அப்படின்னா that is distributed element. RLC பிரிக்க முடியாது. For example transmission line நம்ம பவர் சிஸ்டம் சால்வ் பண்ணும்போது பார்த்தீங்க அப்படின்னா இந்த மாதிரி ஒரு, ஸோ கண்டினியூஸாக we have a resistor, inductor, capacitor over the length of the conductor ஃபுல்லாகவே இந்த மாதிரி ட்ரா பண்ணிடும் டாட் லைன். ஸோ ஆர்எல்சிங்கிறது ஓவரால் டிஸ்ட்ரிபியூட்டர் நெட்வொர்க் ஃபுல்லாகவே ஃபிட்டாக இருக்கும். we cannot able to separate RLCயை செப்பரேட் பண்ண முடியாது. ஒரு கண்டக்டரோட ஒரு ரெண்டு எடுத்துகிட்டு நெக்ஸ்ட் என் போகுது அப்படின்னா 1000 கிலோமீட்டர் 2000 கிலோமீட்டர் போனால் இன் திஸ் கண்டக்டர் கண்டிப்பாக ரெசிஸ்டன்ஸ் இருக்குது. டெஃபினெட்லி இந்த கரண்ட் ஒரு இன்ன கண்டக்டர் the current flows அப்படின்னா சுற்றியும் definitely we have inductance இருக்கும். between one conductor and another conductor இல்லை we have a air as a dielectric medium. ஸோ கண்டிப்பாக அதில் capacitance value. பட் இந்த resistance, inductance, capacitance value நம்ம என்ன செப்பரேட்டாக பிரிக்க முடியாது. that is distributed over the network. So that is called distributed circuit. So this is called lumped circuit, this is called distributed circuit, this is lumped. So separation of R, L and C not possible அப்படின்னா that is lumped, that is called lumped. Separation of RLC, separation of RLC possible, separation of RLC is possible அப்படின்னா that is lumped. Separation of resistance, inductors and capacitor not possible அப்படின்னா that is called distributor. That is called distributor. Clear? So based on this, we have read the definition for lumped and distribution network, note point and definition for lumped and distributor. That is first one, separation of. So in this lumped and distributor, next topic is field theory and network theory. We have two theories, field theory, another one is network theory, right? So this field theory is applicable in the field theory and network theory. எல்லா frequency applicable ஆகும் அப்படின்னா is not applicable. So field theory is applicable only below or above 1 megahertz applicable ஆகும். So field theory is applicable for above or below 1 megahertz. Above or below 1 megahertz you can apply field theory, but the network theory is only below 1 megahertz. So network theory is applicable only in below 1 megahertz or 1 megahertz. So this 1 megahertz ku mele it is not applicable for network theory. Network theory applicable panna mudiyadhu field theory. So for this above or below, so field theory, நம்ம field theory ரெண்டுல பார்த்தோம். So field theory may be a lumped network இருக்கலாம் as well as distributed network வரும். So field theory consists of lumped and distributed. Lumped and distributed la use பண்ண முடியும். Field theory is applicable for lumped and distributed element also. But in the network theory, less than 1 megahertz it is applicable only in a lumped. Is applicable only in lumped. So network theory is applicable only for the lumped elements. So field theory is applicable for lumped as well as distributed element. So field theory is applicable only above or below 1 megahertz supply, but network theory only applicable the frequency range is below 1 megahertz மட்டும்தான் applicable ஆகும். One more note point, very important note point, KCL and KVL. Kirchhoff's voltage law and Kirchhoff's current law is applicable only in below 1 megahertz. So KVL and KCL will fail at high frequency. So KCL and KVL is applicable only in lumped, only in lumped. So KCL and KVL is applicable only in lumped elements, and also KCL, Kirchhoff's current law and Kirchhoff's voltage law is failed in high frequency, failed in high frequency. So it is very important, that is Kirchhoff's voltage law and Kirchhoff's current law is applicable only frequency less than 1 megahertz, that is 1 megahertz, that is lumped elements. So Kirchhoff's voltage law and Kirchhoff's current law is applied only in a lumped network, and KCL, KVL fails at high frequency. High frequency means above 1 megahertz. So அதனால தான் power systemல distribution networkல we are not applying Kirchhoff's voltage law, current law concept, we are not applying. So the next power system பார்க்கும்போது we can understand. Alright. So next element, fifth one, that is time varying and time invariant element. Time varying type last type of the element, time varying and time invariant element. Time varying and time invariant element. The output of the element is varying with respect to time அப்படின்னா that is time varying element. So output of the element will not depends on the time அப்படின்னா that is time invariant element அப்படின்னு அர்த்தம். Right? Example, we are taking one circuit, one resistance, this one resistance, that is R, current flowing through the resistor I, so voltage across the resistance V. Right? So this is for example phase, sorry, this is plus, this is minus. This is one circuit. And also we have one more circuit. Okay, we have a switch. So here also we have a one resistor. We have a resistor switch S1. This is R1, this is R2, current I, so plus minus, right. So this does run the circuit. Okay, we have draw the graph for time varying and time invariant. This is I, this is V, and this is I, and this is V. This is I and this is V. Right. So here நம்ம supply கொடுத்தா அப்படின்னா so voltage, so already படிச்சிட்டோம். So resistance is a linear element, so output of the resistor circuit will be in this, right? So at crossing 0, this is value is R equal to V by for circuit first circuit. So second circuit நம்ம analyze பண்ண போறோம். In the second circuit we have a resistor and we have one switch across inner resistance connected. Across is connected the one more resistance. So for particular, for example, so generally it isn't frequency, this isn't E, this is also R. Okay, S is open. So at the time of S open அப்படின்னா the resistance will be going, resistance in the line with. Okay, so next we are closing the switch. Switch close பண்றேன் now we are closing the switch. Closing the switch, the graph will be in this way. S is closed. S is S is S is closed. S என்னாச்சு now closed. So after a particular time the circuit parameter is changing. So resistance ஓட value வந்து it is getting changed. So அப்போ so this is a it is a time invariant element. It is a time varying element. Time invariant element, this is time varying. So definition, the output of the element is not depends on the time அப்படின்னா that is time invariant element. It is otherwise it is an time invariant element. So that is about time varying and time invariant element. That is that the element output is depends upon time is known as time varying element, otherwise it is called as time invariant element, right? So in the time varying and time invariant element எங்க வருதுன்னா control system படிச்சு ஞாபகம் இருக்கா? Time invariant LINEAR linear time invariant system, linear time variant system அப்படிங்கிறதுலாம் in a control system we are studying time varying element, time invariant element, right? So that's all about types of element பத்தி discuss பண்ணியாச்சு. So we have totally 5 types of element: active, passive, linear, non-linear. Next one is unilateral and bilateral, right? So next lumped and distributed. Last one is time varying and time invariant, right? So totally we discussed about types of